Right, welcome to part 2 of lesson 9, and we're now on to parallel lines. Now, we just recap from before what we know about shapes and things. So we know that everything in the triangle adds to 180, and all the angles are the same. We know that an isosceles triangle, these two are the same and these two are the same. We know that if we go round in a big circle, then that will be 360. And we know that angles on a straight line add to 180. Right. Okay, so we also know that any quadrilateral adds up to 360. Right, so now let's do some more. Now, if we have this kind of scissor effect here, and the scissors can get wider or smaller, the angles within them are called vertically opposite. And it doesn't matter how wide or how small the scissors get, that the red ones are the same as each other, yeah, so the angles are same. The opposite ones, of course, yeah. So that's vertically opposite. Now, let's draw some parallel lines. So we've got a parallel line there, put a little arrow on there, there's another one, and you normally get a line that goes across it like that. Now, there's lots of things that happen within these parallel lines. You can get this angle is the same as this angle because it's in the same sort of position. So you've got a cross at the top and a cross at the bottom, so they're in the same place. And these are called corresponding angles. And sometimes on the GCSE higher, when you're working these things out, they may ask you to give you a reason why x is the same as y, because they're corresponding angles, and they can only be this way if they are between parallel lines. Now there are lots more corresponding angles in here as well, and so anything that's in the same place, that one and that one, they're corresponding, so they're going to be the same as each other, and that one and that one, they will be corresponding as well. Now I've run out of colours. That one and that one. So there's 4 sets of corresponding angles there. Right, so that's corresponding. Then some more parallel lines. And this one and this one are the same as each other because they are called alternate angles. And there are more alternate angles in here as always. So we've got these ones on the inside and these ones on the outside. So we've got 2 sets of alternate angles and they will be the same as each other. And the red and the black will add up to 180. Yeah. So the third little rule to try and remember is this one and this one is this angle and this angle. Now because they're in between parallel lines, if we were to walk along there in a westerly direction, then go up there and then go over there in an east, we've turned through 180 degrees. So these are called allied angles, and they add to 180. So of course if you know one, you can subtract it from 180 and you'll find the other. Now there is one other set of allied angles in here as well, which is on the other side of the line, which is these two, the blue ones. So we've got allied angles. let's go back up. Now, it is not uncommon for us to have this and this and this, and you come across the question and you think, my goodness, yeah, this is one of those angles between parallel lines questions, but it isn't, because really it's an algebra question that you need to know a little bit about parallel lines. Minus 15. So x minus 15 is the size of the angle at the bottom. 3x plus 75 is the size of the angle at the top. And it's going to tell you or ask you nicely to find the value of x. Now the only way that you can do this is to know that both these angles together add to 180 because they are allied. So we've got 3x plus 75 plus x minus 15 will equal 180 degrees. So now we're down to the algebra bit. So we need to find out what x is. So first of all, we'll collect like terms. So we've got 4x, 75 take away 15 is 60, equals 180. Now this is familiar, linear equation. Let's take away 60 from both sides. So we're left with 4x equals 120. Now divide by 4. So x is 120 divided by 4, which equals 30 degrees. They're not always algebra. Some of them are just pure. Let's try and find the angle. So they've got this and this. Not very clear, but these two are supposed to be parallel to each other, and they do this by spinning. You get familiar with the parallel lines going that way, yeah, and then turn it round. So just turn your exam paper round if you want to try and help you. So this is 80 and this is 65, and you'd be asked to find x and y. Right, so x is in this shape here, which is an alternate angle between the two parallel lines. So x is going to be equal to 65, yeah, because it's the same as that one. Now this other one here is between two parallel lines, but it's this sort of thing. Now they are allied angles, so they add to 180. So y equals 180 minus 80, which equals 100. Yep. Not very good writing with that big pen. Let's go back to the blue. So sometimes it takes a while to see these things. So we've got a parallel line there, which is parallel to this. So we're going to go there and there. Now I've deliberately, as best as I could, make them different slope. Sometimes you will get them that look the same and you think, oh, I know what this is, but don't be fooled because nothing is drawn to scale. You cannot measure anything with a protractor or anything. So we're going to have 70 there, and y is up there, 120, and x is down there. Now, lots of different ways, and we'll also find z as well, which is down there. Z. Lots of ways to find all these things. So, first of all, we'll find, I suppose we can, what can we find? What can we find? We'll try and find x. So, 120 plus this one is on this straight line. Therefore, that one will be 180 minus 120, which equals 60. So that's going to be 60. Now then we've got an alternate angle there. So x will be equal to 60. That's 60 there. What about this one? An alternate angle there makes that 70. And then y, because it's on this straight line, is going to be y equals 180 minus 70, which equals 110. And z. So there's the triangle there, and the triangle all adds up to 180. And we've got vertically opposite there, which gives that 70, and this is now 60. So if we add the 60 and the 70 together, we get 130, and we subtract that from 180, which gives us 50 degrees. Now, one other thing to mention when we're doing these is if we have a shape like this, we're quite familiar with saying that's angle X, that's angle Y, Z, and W, yeah? So the angles are named within it, but there is another way to name the angles as well, and this is more common. We name the shape from the corners A, B, C, D. Now, this angle up the top, start with X. This one down here, if we're only looking at the corners, D is in the middle. So this one is called A, D, C. You see, it's D, which is in the middle of A and C. This one up here is going to be D, A, B. This one will be A, B, C, and this one will be B, C, D. Now, the reason why it's done like that is if you have doesn't matter, if we have this sort of affair and we've got that and that, and we've got A, B, C, D, this angle here will be A, B, D. Yeah, that's just the top bit. This angle here will be D, B, C. It doesn't really matter whether you get the A's and the D's and the D's and the C's the other way around, as long as you get the main one in the middle. And the whole angle, this thing, is going to be A, B, C. So that's just another way of naming the angles. Okay, so I think that was it for this lesson. Okay.